Okay, so far in class, when we've been graphing sine and cosine functions, we've been graphing the same picture every single day. What we're going to be doing today is we're going to be given an axis that we can't adjust or scale any differently, so it's going to force us to draw a slightly different picture. But we're going to follow the same general procedures. So for example 1 here, it says y equals sine of 2x plus 1. We still have to identify the amplitude, which in this case, there's no number in front, so the amplitude's just going to be 1. Then we identify the period. And the way we identify the period of the function is figure out what the b value is. So b equals 2. And remember that the period is always going to be 2 pi over b, which in this case is 2 pi over 2. So the period is just pi. And then finally, the vertical shift in this problem is going to be whatever's added or subtracted at the end, so it's 1. So that's where the midline is. It's like k equals 1. So when I'm going to plot this, the first thing I want to do is I want to draw the vertical line, the midline. Sorry, horizontal line, not vertical. But k equals 1. There's my midline. And then I'm going to plot the 5 key points. So just thinking about what we've done previously, we would start by saying, okay, here's the midline. The amplitude is 1, so we're going up to 2 and down to 0. And then because this is a sine function, our 5 key points are going to be minimum, or 0, maximum, 0, minimum, 0. And that's what our graph is supposed to look like for one period of the function. And then we know one period is going to end at pi. So half of the period is going to be pi over 2, a quarter is going to be pi over 4, and 3/4 is 3 pi over 4. So now that we know those values, we can kind of translate that onto our graph down below. We have 0, and then we know we have a maximum of pi over 4, a 0 at pi over 2, a minimum at 3 pi over 4, a 0 at pi. But we don't want to just sketch one period now. We want to sketch for the entire graph. So we'll just have to keep it going and plot both directions until we're off the graph. So it looks like we're going to have 3 full periods of the function sketched here. And then we put arrows on it to show, hey, this is going to continue on forever. But that's the idea we're going to work on now, is think about how we sketch this on a given axis, and we're just going to sketch to the very end of the axis. All right, the 5 key points we could technically use. The same points as we had on the graph to our right. We're going to say pi over 4 comma 2. That was the maximum. The minimum is going to be 3 pi over 4 comma 0, and then the intercepts were 0 comma 1, pi over 2 comma 1, and then finally pi comma 1. Those would be the 3 intercepts for identifying those 5 key points. All right, that's what it's going to look like now. Okay, and again, the key here is we do want to complete the sketch until your function leaves the provided grid on both sides. All right, that's the whole idea here. We're just practicing that. So it might be helpful to sketch the one period of the function first, and then use that information to help us sketch the entire function. That's what we're looking at for this first example. Okay, let's move on to example number 2 now, which is asking us to graph y equals 5 times cosine of x plus pi over 2. So there's a little phase shift going on here. There's some horizontal shift. First of all, 5, that's going to represent our amplitude. So we'll say a equals 5. The period of the function, there's no real b value in front of the x, so the period is just going to be 2 pi. The horizontal shift, remember, is always going to be the opposite sign of what we think. So it's really going to be negative pi over 2, or we could say pi over 2 units left. All right. So we'll plot the 5 key points by translating the key points of y equals a times cosine b of x horizontally h units. So we're going to move h units to the left. All right, that's the key for this problem. So if I were to sketch this problem initially, all right, the amplitude is 5. The period is normally ending at 2 pi, but I'm going to have to do 2 pi minus pi over 2. So it's really ending at 3 pi over 2. And that means over here it's going to be at negative pi over 2 is where it's starting. Okay, because I'm shifting everything pi over 2 units. So that means normally my halfway point is pi, but I'm subtracting a pi over 2 from it. And that's how I end up getting my new period of this function. Since it's a cosine function, I start at the maximum value, I drop to 0, down to the minimum, back to 0, back to the maximum. And there's what my cosine function looks like for this problem. Now I can see that it's starting at a maximum of 5 and a minimum of and it's starting at negative pi over 2, but the graph starts at pi over 2. So the graph's really going to start at the minimum value here. So this doesn't work very well, so we'll just make that negative 5, make that a positive 5. So we're going to go from negative 5 to positive 5 here. Start at the minimum, and then at pi, that's going to be back at the 0. And then at 3 pi over 2, it's going to be at the maximum. At 2 pi, it's going to be back at 0. And that's how we'll sketch this function, which turns out this sketch is not even a full period of the function, but that's how we're going to complete this one. If we were identifying 5 key points here, we could use the 5 key points from the graph that we sketched, or we can use what's available for us here, which is only 4 points. The maximum here is 3 pi over 2 comma 5. The minimum is pi over 2 comma negative 5. And then the intercepts are pi comma 0, 2 pi comma 0. So it ends up only being 4 points in this case instead of 5 because it's not a full period. All right, so that covers example number 2, what we're looking at. All right, so the last example here, example number 3. This one, I give you the graph, and I'm asking you to identify the amplitude and the period. That's very similar to what we did on the homework, problems 1 through 3 of assignment number 21. A period always goes from peak to peak. So I can see here the period is pi over 2. The amplitude goes from the midline to the maximum. So the midline's from 0. The maximum's up at 2, so the amplitude is 2. I'm going to calculate the b value of the graph. What that means now is I'm saying, okay, I know a period is typically 2 pi over b. This period happens to be pi over 2. So I'm going to solve for b. So if I multiply both sides by b, I'm going to get 2 pi equals pi over 2 times b. And then I'm going to divide both sides by 2 over pi, or multiply both sides by the reciprocal, which is 2 over pi, to get b by itself. So the pi's go away, and I get 4 equals b. So there's my b value. I can determine if the function's sine or cosine. That's step 3. Because it's starting at a maximum here, and then ending at a maximum at pi over 2, this looks like it's going to be a cosine function. Sines tend to start at the midline. So this is definitely a cosine function. The last part, I'm going to write an equation. Y equals, my amplitude is 2. It's a cosine function. My b value is 4. So y equals 2 times cosine 4x. That's how I put it all together when it's all said and done. A represents the 2. B represents the 4. And it's a cosine function that I identified. So that covers problems 1 through 3 here. These 3 examples. Now, for some practice, I want you guys to try these 3 problems. So given the axes, so you might want to sketch a little graph first, and then go ahead and complete your axes from that. All right, that's for problems A, B, and C. All right, so give that a try now. Okay, so giving you some time. Hopefully you guys can check your answers now. And if you have any questions, please pop into some office hours tomorrow when I'm available. All right, thanks so much, you guys. Have a great day.